In this lesson, we shall focus on mathematics, MATH141 calculus, UKZN module. We shall look at techniques of integration and a lot more. Now, there is this question, and now we shall also use the reduction formula that appears, or reduction formula that appears at the bottom. We shall be looking at a wide range of questions, but these are some of the questions in the TAT, the latest and older questions as well. We shall also give some attention. For instance, if you look at this one as the integral of the tangent cubed of 6x. Okay, now obviously we need to use the reduction formula, but we still can do without it. And in the exam and many other assessments, it will be very interesting to see exactly how this one can be solved. And so let us devote some time to actually solve this particular question and look at how best this particular question can actually be solved. Right, so if you're looking at the tangent cubed, right, of x, and so what becomes the method to solve this particular question? And we proceed as follows. So first things first, this can be seen as the integral of, right, can be seen as the integral of the tangent squared. Can be seen as the integral of the tangent squared of 6x, the tangent of 6x dx. Meaning we have the integral of, what is the tangent squared? Now, we need to remember something that from the school curriculum. From the school curriculum, we have the following. Right, we have that the sine squared of x is 1. Divide through by the cosine squared. Plus 1. All right, right. So obviously, okay, that's fine. So the reduction formula is one formula that is used to solve problems, and it is actually done in the same way, sort of derived in the same way that we're solving now. And so obviously we shall do it because it is below, so we're yet to reach it. And so now, but we're gonna just do it right now as it is. But by the time we reach it, then we shall also use the reduction formula to do this. But obviously, in general, the reduction formula, it's not a formula you can always remember all the time. And so, yeah, you'll actually normally remember the methods than reduction formula because there were too many. The reduction formula, okay, that's fine. So it is the formula that we're going to prove in a little bit of time. So, yeah. And therefore it can be used to solve this particular problem. Right, now, we're moving to the reduction formula, but I'm just emphasizing the fact that this problem can be done without using that, and which is the most preferable way of learning. Right, but we shall also do this problem using the reduction formula below. Okay, right, so that when you have sine squared over cosine squared, it is the tangent squared. The cosine squared over the cosine squared is 1, which equals the secant squared, which is the secant squared, like that. Right. Now, so that whenever you have the 10 squared, you can put the secant squared. So which is the tangent of 6x. So that in the end, you would have the secant squared of the tangent of 6x. Right. Okay, so this one is the secant squared of 6x. Right, so the tangent squared is the secant squared minus 1. So here you'd have the secant squared of 6x, the secant squared of 6x, and then we have the tangent of 6x minus the integral of the secant squared of 6x, and then the tangent of 6x dx. Right, so we have this. Now, if you let u to be the tangent, then the derivative of the tangent is what? The derivative of the tangent is the secant squared. Okay. Look. Now, if you check the multiplication, this must only be the tangent. So this one is only going to become the tangent of 6x dx. Right. In which case, okay, it's by multiplication, because if you distribute this one, it's going to multiply this, it's going to multiply that as well. Right, so if you let u to be the tangent, then the derivative of the tangent is the secant squared. So that's 1/6. So, okay, so there's going to be 1/6 that's going to come out of this, but from the angle, but also the secant, the tangent, because you let u to be the tangent. If you let u to be the tangent, the derivative of the tangent is going to have the 1/6. Okay, let me just show the steps here, I think, to be fair, than to just be too brief. So what we're going to do is we're going to let u to be the tangent of 6x. This means that the du is the secant squared 6x dx. So that in the end, which is the secant to the 6th power, minus tangent of 6x. So you let u du is 6th. Dx. So that now you have the secant. We have the secant to the 6th power, or rather the secant squared of that, and then the tangent is u. The dx is du over 6, the secant squared of 6x. Okay, this one is okay, which is the tangent of 6x dx. Right, now when you check carefully, therefore these secant cancels, and then you have the 1/6. The integral of u du minus the integral of the tangent of 6x dx, which are 1/6, the integral, which is u squared out of 2 minus 1/6. Okay, what is the integral of the tangent? Right, the integral of the tangent is seen as which is sin x over cosine x. Okay, now this, the derivative of this one, you would need, okay, this one I know very well. It's very basic, it's there in the books. The derivative of the cosine is negative sine, but we put minus minus here to quickly derive the formula for the integral of the tangent of 10x. Negative 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 is plus. The derivative of the cosine is minus sine. So that the integral of this, so that the integral of the tangent is minus 0 ln of that, but you can write it as the ln of the secant of x plus c, because it's like 1 over cosine. Right. That is 1 over 6 here. Okay, so this one is going to be 1 over 6. Because of the 6x, it becomes 1 over each time you integrate. And therefore, it becomes the ln of the sec of 6x plus c. 1 out of 12. What is the u? Minus 1 out of 6. All right, and we have this. And therefore, this becomes the answer to the question. But once again, with this answer, we want to use also the reduction formula to derive the answer to this. Okay. The reduction formula, it's going to be proven below. That is why they said without using the reduction formula. Okay. So without using the reduction formula below, because the reduction formula is there, and we've done without using the reduction formula, but yeah, we can use the reduction formula as well to sort of arrive at the answer to this particular question and see what to do exactly here. So yeah, think about it and sort of make sure that you are able to sort of understand this particular question very well. Right, so make sure you understand this particular question very well. The u dot and the derivative. Okay. Right, so you have exactly that. You have exactly that. Let's see what we've got here. Mm-hmm. 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 Right, so yeah, we get exactly this. See now, this is actually what we have. This is actually what we get and what we have here. Right, this is what we have. And once again, there are a couple of ways to do this, but this is certainly one way to do this particular question on the integration part. Once again, I mean, they said without using the reduction formula. Once again, I mean, you can still do with it, but they said don't use it because it's going to be too easy. Because you're just going to apply the formula without going through the steps. But also, what other method exists that can be used to do this one? Okay, there are too many methods that exist. So yeah, we're good. Okay, let's continue. Now, let us do the next one. So we're going to also do part E of this. Right, so now this is the method that we can use. And so I'm pausing because it's very important to realize that there are a wide range of techniques of integration that can be used. Right, so it's very, very important. Right. So it is something that you need to take into account. I'm gonna actually obviously use a wide range of techniques to solve this. If this is one method, what other methods can be used to do D, for example? Right, so it is most certainly something very important and must be done, must be learned. Okay, so just take note of that and see what other, I want to elaborate on a wide range of methods that can surely be used to solve this particular problem and allow us to determine this with utmost precision, Right, so yeah, there are too many ways. So this is fine. But what other methods exist? For example, I'm just going to elaborate on that because if you look at this part D, you can also write it like this and also get to this point. And when you get to this point, in other words, what I'm saying is, I want to elaborate on the fact that the integral of the tangent cubed of 6x dx is also the same as, like we saw here, we're going to use the same thing like 10 squared is 6 squared minus 1. 10 squared is 6 squared minus 1. So we're going to use it here wherever, yeah, so you can break it down to the 10 squared in that. So which is exactly the secant of 6x dx. Right. So the 10 squared is 6 squared of 6x minus 1. 6x dx. So that is what we have. Okay, yar. This is the 10, please. And this is also 10. So you have 10 cubed. So it becomes a 10. All right, so we distribute. So which is 6x dx minus the integral of the tangent of 6x. All right, so now when you get to this point, you can let, for this one, you can let u be the secant of 6x. The u becomes 6. The secant of 6x, 10x, 6x dx. Okay, so in the end, so it's 6x. Six x minus the integral of the tangent of 6x dx. So that now in the end, you let u to be the secant. So you substitute one of this. And then now Yeah, I mean, there are many ways to do this. So you can make dx a subject here. So dx becomes du divided by dx divided by, that is dx is du divided by 60 secant of 6x, the tangent of 6x. All right. 6x, the tangent of 6x. What is the dx? Divided by 6 the secant tangent of 6x. Right, so we're going to simplify this one. The secant and the tangent cancel out. Right, I mean, I'm just saying this is another way to do the question. We've done it one way, and then this is another way to do it. And then now you have the integral of the tangent of 6x dx. All right. Meaning you'd have also the integral of 1 over 6. One over 6 u du minus the integral of the tangent of 6x dx. So this is 1 over 6. The integral of this one is u squared out of 2 minus the integral of the tangent would be 1 out of 6. The ln of the secant of 6x plus c. Because the integral of the tangent it's the ln, but because of the 6x, then you put 1 over. This one becomes 1/12 u squared minus 1 out of 6. The secant of 6x. So that now the u is the secant of 6x. One out of 6, the ln of the secant of 6x plus c. Okay, so this answer, okay, this is what answer we got. Obviously, without using the reduction formula, we got this answer. Or the other answer. What is the other answer? Check. Is this one 1 out of 12, 10 squared, 6x minus 1/6, the ln of the secant. So they are, it's 1/12, 10 squared of 6x minus 1 out of 6, the ln of the secant of 6x plus c. Yeah, in which case, therefore, you can get this one or this. So both answers are correct. Although they look a little bit different from each other, but they are correct. They are correct. So yeah, there's something you need to take note of. And understand the differences in the answers. Okay, we're looking at E now. The integral from 0 to pi of 6 secant cubed of 2 theta, the tangent of 2 theta d theta. All right, and want to do this one. So to do this particular problem is the same as what I was saying now. The easiest way to do this is to break it down. Okay, this is just one way. So the cube can be broken down to a square and that. Which is the tangent of 2 theta d theta. Right, so, okay, we have that. Okay, so that we have this. Okay, we know that obviously the secant cubed is actually can be written like this. Okay, as the secant squared and then times the secant. Upon careful examination, we perform substitution and we let u be the secant of 2 theta. Then we can find the derivative of this. The derivative of the secant is the secant tan, secant tangent, but there's a 2 that's going to come out from using the chain rule. D theta. Okay, so now we're going to change the limits of integration from theta to u. Pi to 6. Right, so u is secant of 2 theta, but the secant of 0 is 1. You put 2, which is the secant of pi over 3. The secant of pi over 3 is going to become exactly a 2. Right, so that this integral here is going to be the integral of the following. So it's going to be integral from, instead of 0 to pi over 6, we're going to integrate from 1 to 2. And then we call it the secant of 2 theta so that it becomes u squared. See, this is the tangent of 2 theta. D theta is du divided by 2, the secant of 2 theta, the tangent of 2 theta. Okay, so this is exactly u squared du. So this is 1 out of 3 that. So it's 2 to the 3 minus that, which is 8, which is 7 out of 6. 7 out of 6. Right, so check this out, and this is the correct answer to the question. So by and large, that would be one way to do that question. So it is 7 out of 6. And the 7 out of 6, you can write it like that, but you can also write it as a mixed number. So the 7 out of 6, you can also write it as what? The 7 out of 6, you can also write it as a mixed number, which is 6 cosine times into that. So you are able to see that, as a matter of fact, yeah, it is 7 out of 6. They wrote it that way. So it's okay. Move to the next one. Okay, we're going to do these types of problems now where you have multiple angles that are involved. Now, dealing with problems involving multiple angles is something of great interest to us. But yeah, we shall work backwards to the other parts also. I understand that some of the things here, maybe you are still seeing. But some of these are really from school straight away, and they offer you an opportunity to learn. But so okay, look. Now, to deal with this one, you have this sign. Okay, now this one is sine cosine, so you use the formula a plus b. Right, the sine of a plus b is the sine of A cosine B plus cosine A sine B. And then you have the sine of A minus B sine A cosine B minus cosine A the sine of B. Now this equation 1, equation 2, 1 plus 2, add them up. Adding these two equations up is actually the sine of A plus B, the sine of A minus B. Right, if you add them up, then this is exactly the same as 2 sine A cosine B. I'm just deriving the formulas that I'm going to be using here. In particular, we're deriving the formula we're going to be using like to do A and B. Yeah, in particular to do A. So you divide by 2, which is 1/2. B plus the sine of A minus B, which is exactly the sine of A cosine B. Okay, you get this. So this is what you get. So now we're going to use that formula here. So in other words, if you have this formula and you have the sine of 3x cosine 5x, according to this, it's going to become exactly the sine of right. So it's going to become the sine of this is our A and that is our B. So it's going to be 3x plus 5x, 3x minus 5x. Which is exactly the sine of 8x. And then this is minus 2x. Five x. So that you have the sine of 3x cosine 5x and then you have the sine of 5x of 2x. Right, so in other words, if we are dealing with this one here, we're going to use exactly this formula. We have the integral of the sine of 3x cosine 5x. It's 1/2. You add the angles up. And then plus, you subtract the angles. So you add the angles up and then you subtract the angles. Which is exactly the sine of 8x minus 2x. Which is the integral of 8x. Yes, please. Okay, that's good. So now we use this formula when we are dealing with the products of the trigonometric functions of multiple angles, because now we just have the sine of 3x and then the cosine of 5x. So the sine of 3x, the cosine of 5x, we need to use this formula. What is the formula? The formula for that one is exactly this one here. It's exactly this one here. So that the sine A cosine B is the same as 1/2 the sine of A plus B plus the sine of A minus B. Right. So that in the end, you first put half and then you add the two angles and then you subtract them. But you say this the A minus the B, the angle of the sine minus that of the cosine. So this formula you need to derive. We're going to derive another one there, but you need to remember these in the exam. But yeah, but you see, the thing is you can always forget this formula. So sometimes like remembering how to derive them becomes so important. Like it's easy for me to remember the sine of A plus B, the sine of A minus B, then I can derive all the others, the other formulas, you know? And so now we have that. So let's continue. Okay, we're going to see exactly what we're getting. So now this means that it's 1/2 the sine of 8x. Now the sine is an odd function, so the negative goes through, and then we have minus 1/2 the integral of the sine of 2x dx. And this is 1/8. What is the integral of the cosine of the sine? Is the negative cosine. Is negative cosine of 8x. So this is negative cosine of 8x and then minus 1/2. This one is negative 1/2 cosine of double x plus c minus 1 out of 16. Cosine of 8x, which is cosine of 2x. All right, so okay, this is what we have. So let us check what answer we get. So this one is exactly the answer we got. It's 1/4 cosine 2x plus c minus 1 over 16 cosine of 8x plus c. It's exactly the answer we got. So we actually have solved the problem correctly. In other words, whenever you have the integral of the sine of 3x cosine 5x dx, it is the same as this one, 1/4. So these things, and the way you need to learn them, you need to repeat what I've done because it's still new to you, but yeah, you will get familiar with this. You'll become very familiar with it. Right, so that when you have the integral of the sine of 3x cosine 5x is 1/4 cosine 2x minus 1 over 16 cosine 8x. So that is something you need to know. Something you need to know. Okay, so we're moving on now to the second part. Is the second part. Okay, R. And so, which means that it is cosine of x over 2, cosine of x over 3, dx. Okay, to do this one now is the same thing. Because now in school, we are taught cosine of a plus b. And then, but in school, we're also taught the cosine of a minus b. So you need to derive the formula that is going to have cosine formula from this. So now you need to add the two formulas. So you do here cosine A, cosine B minus sine A, sine B. And then here you do cosine A, cosine B plus sine A, sine B. Okay, now you have this equation 1 and this is equation 2, and then you're going to add them up, 1 plus 2. So it is A plus B plus the cosine of A minus B, which is 2 cosine A cosine B. Cosine of A plus B. So, and then this one is cosine of A minus B. Okay, divide it by 2 and then you get cosine A cosine B. All right, so that in the end, cosine A cosine B, you write it like this. So it's going to cosine A cosine B, you just, in the exam, you write 1/2. Then cosine A cosine B, you add the two angles up. So it's going to be x over 2 and then x over 3. You add the angles. And then we have plus the cosine. And then you take this one. X over 2, you minus x over 3. Dx. All right, so we have this. And then our dx. And then this one is 3 minus 2. 3 minus 2, which is x out of 6. All right, so now okay, we continue. So now we would have 1/2. Okay, if you integrate this one, the integral of the cosine is sine. But now you write like this. Because of the coefficient of the x, you write 1 over 5 out of 6. And then you write the sine of 5x out of 6. And then you have 1/2 like this, 1 out of 1 out of 6. And then you write the sine of x out of 6 plus c. You invert this one. If you invert this one now, it becomes 6 out of 5. 6 divided by 2 is 3 out of 5. The sine of this. So you bring the 6 up, which becomes exactly 3. The sine of x out of 6 plus c. It's exactly the answer. You see, in part B, we've got the answer because it's 3 out of 5, the sine of 5 out of 6x, plus 3, the sine of 1 over 6x plus c. So we've been able to solve problem B correctly as well. So it's something that you take note of. But how did we actually solve this? So we actually had to derive some other formulas from trigonometry and then use them to solve the problem. Now we continue now to solve for part C. How would you solve part C? Now part C now is a very interesting one, but you're able to see that now there are several multiple angles that are involved here. Right now, because there are several multiple angles that are involved here, you therefore obviously need to look at what also the answer contains. So you'd have that this is a 6, and that's a 4, and that's a 2. Okay. So you have that. Okay. So you have a 6 and a 4 and a 2. So you need to look at these and think very carefully and look at what you can do to solve this particular problem. So let us look at it. Now we want to do part C, and part C is about a sine. Yeah, so you need to multiply this. The question is, what do you do to multiply this? Or to rather solve this? Right, to solve this, obviously you need to think, but think very, very carefully. Right, and you need to look at this and reason in terms of how best this can be done. But also, we have learned multiple angles, so you might wish to associate some of this because you're able to see that here there is a 6x, and there is a 4x, and there is also 2x. So what you can do, maybe you can group like this. And then now try to deal with this, and then also try to deal with the parts. So we might need to, because it's only sine, sine, sine here. So let's start here like this. So now it is sine which is sine A cosine B plus cosine A sine B. And then you write the minus. The minus, okay, because it's sine sine, then you will need only the cosine function because it's the only one that repeats. So you would need cosine of A minus B. All right, which is cosine A cosine B plus sine A sine B. Plus B. Cosine A cosine B sine A sine B. So that you add them up. You add them up. Cosine of A minus B. Okay, now you need to subtract them. You need to subtract this. All right, you subtract this like 1 minus 2. A plus B. So you have this minus that, which is 2 cosine A cosine B. And then you have 1/2. And then you have minus cosine A plus B, which is exactly cosine A cosine B. Right. Let me see what we've got. What I'm saying here is that this is going to be sine sine. Because if you say this minus that, then it's going to be 2 sine. Sine sine here. is going to be sine A, sine B. It's going to be sine A, sine B. And therefore, this is exactly what. So you can group these ones, maybe. Right, so grouping those would give us, for example, the integral of the sine of x. So this one, the sine A, sine B, according to this formula, is going to be 1/2 the sine A, sine B is going to be 1/2 of the cosine of A minus B, which is 2x minus 3x. And then 2x plus 3x. Right, and then you put a dx here, like that. So that you have the sine of x, 1/2. And then here it's 2x minus 3x, which is minus x, the cosine of 5x. Right, so, okay. So now, this is what you have. You can distribute everything. So this is 1/2 the integral of the sine of x, cosine x. So cosine minus x is the same as cosine x, dx. Minus, so there's a minus here, 1/2 the integral of the sine of x, the cosine 5x, dx. Like this. So now we're back to the sine cosine. What is the rule about sine cosine? Sine cosine, this is the formula. So sine cosine is half. You add the two angles and then you subtract them. You add the two angles and you subtract them, the angle for the sine minus that of the cosine. So which means that you're going to start and say the integral of sine x, sine 2x, sine 3x. Dx is equal to 1/2 the integral of sine x, cosine x dx. Sine x, cosine x dx minus 1/2 sine x, cosine 5x dx. So that in the end, you have 1/2, but to, okay, you first, okay, this one you can easily do. You can even let u be, let me see. Can even let u be sine and then differentiate. Simultaneously, you can use our same formula so that it is 1/2. You add up the angles, because if you have sine cosine, okay, if you have sine cosine, then it becomes sine sine, but you add up and then subtract. Okay, you add up and then you subtract, And then if you subtract, and then it's going to be 0. That's fine. Can do that. Yeah, so it's going to simplify nicely. And then it's going to just be half sine 2x, which is correct. And then you also come to this one here. This one is the same as the sine cosine. So what you do is you put 1/2. You write the sine because it becomes sine whenever it's sine cosine, and then you add up the two angles. So it's going to be x plus 5x plus the sine of x minus 5x dx. Okay, so that in the end, even here you put dx. So half is 1/4. The integral of the sine of 2x dx minus 1/4 the integral of the sine of 6x minus the sine of 4x. Okay, but yeah, it's gonna like go out like that because x minus 5x is minus, but through the sign it becomes the minus goes through. Right, so you have 1/4. The integral of the sine is 1/2 cosine is minus. It's minus. So the integral of the sine is minus cosine. So it becomes minus 1/2 cosine 2x. So the integral of this one is minus cosine, but it becomes this. So now it becomes exactly cosine 4x. So that at this point it becomes minus 1/8 cosine 2x, and then this one negative by negative is plus 4/6 is 1/24 cosine of 6x, and then this is 4/4, 16 cosine 4x plus c. So now you have 1/24 the cosine of 6x, and then let's check the signs here. Let us check the sign. So this negative by negative, it's going to be plus. It's going to be plus, so that this is going to be exactly minus. So that in the end, we have exactly this one, which is 1/24 cosine 6x minus 1/16 cosine 4x minus 1/8 cosine 2x plus c. Right, so that will be the answer to the part C, and we've got exactly the same answer. So check that out and make sure you sort of understand that. We're going to be working backward to the tarts, the old tarts, okay? And then also, but we shall be actually making a recap and doing also the 142, the other module 142 also. Because now it's not only about 141, but also we must go to the areas, we must go to the volumes and discuss volumes and areas as well. The volumes of revolution and other things, and move forward. Okay. Okay, if you look at 3A, we continue to investigate the 3A part. Okay, now you spoke about the reduction formula, and this is the reduction formula. So this reduction formula is often proven by using integration by parts. or equivalent results. And so now we're going to use evaluate this one. Okay. Okay. Here they said hands. Evaluate this. And because they said hands, then you're going to be using the reduction formula. But now you need to pause to reason out and see how best this can be done. But also, I mean, you asked earlier to say what is particularly important about the reduction formula. What is particularly important about the reduction formula? It is something that obviously is very key to master. And therefore, it's very important that also you simultaneously acquire the skill to deal with these kinds of problems here. To deal with these kinds of problems here. Right, so we have the following. Okay, let us look at the tangent to the nth power, and we want to, this is called the reduction formula, this one, because it reduces the power from n to lesser powers. Okay, like n minus 1, n minus 2. Now, let's look at that and reason together, because we need to derive this particular reduction formula. And we need to reason and see how best this can be actually done. And so we reflect on this and see what we can do. The way to do this one here is to attempt to use integration by parts. And now, if you look at how integration by parts can be used, or an equivalent method to that, but also how best can these be studied? How best can these be solved? Right, so we continue to analyze that. Right, we continue to precisely analyze these and see what can be achieved here as a matter of fact. Right, so I'm pausing because I want to reason very carefully. I want to make sure that we prove these with so much simplicity. Right, so to do this, we're going to proceed as follows. We need to break it down to, for instance, the tangent. So let's look at 3a. Let's look at 3a. So it is the integral of x dx. Which is the tangent of n minus 2x. Which is 2x dx. Okay, you can write like this. Right, so you can write exactly that way. And once you get to this point, you can be in a position to break it down to n minus 2x. And then what is 10 squared? We saw that tangent squared is secant squared minus 1 dx. So that in the end, we have n minus 2x, sec squared. Okay. Okay, so you have the integral here of 10 minus 2x dx. You see, we're getting close to it because you already have this one. This is this one. But now you need to deal with this particular integral. So to deal with this particular integral, you let. Right, so I'm going to do it in blue color. So you can let u be equal to 10x du. Okay, so which is sec squared x dx. So that in the end, then you would have u here, because u is 10x, but it's going to be u to the power n minus 2. And then you can look at this. What is sec squared x dx? Sec squared x dx is du. Sec squared x dx. Sec squared x dx is du. So you can put du here. Minus the integral of x tangent n minus 2 x dx. By the rules of integration, this one is going to be 1 over n minus 2 plus 1. U to the n minus 2 plus 1. Minus now the integral, so you're going to add, we can add a c, the r, it's fine. And then you have the minus the integral. So now we have n minus 1 from the minus 2 plus 1. U to the power n minus 1 minus the integral of n minus 2x dx. 1 over n minus 1. Check this out. So this is 1 over n minus 1. And then the u is going to be tangent of n minus 1 x minus the integral n minus 2x dx. And this is the reduction formula. That is exactly the reduction formula. So we have been able to derive it by just not even using integration by parts, but by just substitution, we're able to get the answer. So that the integral of the tangent to the nth power of x dx is 1 over n minus 1, the tangent to the n minus 1 of x, minus the integral of the tangent of the power n minus 2 x dx. So now you note that one and make sure you sort of understand it. And we shall continue to look at the next part. So now to do that, because it said hence, so we're just going to use the reduction formula to do that. It's called a reduction formula because it's sort of what it does is it reduces the powers of the function, right? Making the powers even much less. So that's what we have. That is what we have. So, right, we're good. We're so good. We're so good. We're so good. Okay, let's continue. We continue. All right. Now we're going to do the next one. Part B. Right, in view of part B, we're going to be doing this one using the reduction formula in part B. Now, using the reduction formula in part B, okay, these things you need to like repeat them. And this will be the end. You see, this is the last one for this part 3, part 2. Right, so we would have done like all the questions in this part. And then now we're going to just be doing this one. So to do this one, you need to first use substitution so that it looks exactly like this to avoid mistakes. So you'd have the tangent to the fifth power of 1 of x, and then it is divided by x squared dx. We let u be equal to 1 of x, which is x to the power minus 1. Du is minus x to the minus 2 dx, which means that minus x squared du is dx. Come to this, and then now come here and say the tangent to the fifth power. Here you have the tangent to the fifth power, then here you have u, and then just divided by exactly x squared, but the dx is minus x squared du. All right, and therefore this is negative. The tangent to the fifth power of u du. Okay. Yeah. Now, this one is exactly like this. And then n is what? N is 5. N is 5. Okay, so if n is 5, then you can, it's minus, okay, it's minus. It's minus. So now, if it is minus like this, according to these, it's 1 over 5 minus 1. Arctangent of 5 minus 1 x minus the integral of the tangent of 5 minus 2x dx, which is minus 1 out of 4. Arctan of 4x minus the integral of 3x dx. Which is 4x minus the integral. Now you come to the tangent cubed. When you come to the tangent cubed, then we're going to use this part. So the tangent cubed, according to this, okay, yeah, but this negative is going to multiply out here, please, giving us a plus. This negative is going to multiply, giving us a plus, so that this one is going to be plus. But the tangent cubed, you're going to have 1 over 3 minus 1, which is 2. 2x minus the integral. Then you have 3 minus 1, which is 3 minus 2, which is 10x dx. Yup. Minus 1 over 4. And then it is plus 1 out of 2 arctan squared, and then the integral of the tangent. What is the integral of the tangent? The integral of the tangent is minus the natural log of the cosine x. Right. Okay, so yeah, look. So these things here, all the angles here must become u. Everything must become u here. Everything must become u. Everything must become u. U, u, du, u, u, du, u, 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 du, u, u. Okay, and then this one is going to be u plus c. So that if you look very carefully, then you're going to write the answer like at the top here. So what is the answer? Minus 1 out of 4. The tangent of to the fourth power of u. What is u? U is 1 over x. So you put 1 over x here. And then here you have like 1/2 the tangent squared of 1 over x for this one. We have negative by negative, which gives us a plus the natural log of the cosine of the u is 1 over x plus c. All right, so take a look at that one. Okay. So this is exactly the answer they got here. Minus 1/4 tangent to the 4th power of 1 over x, 1/2 the tangent squared of 1 over x, and then plus the ln of the cosine of 1 over x plus c. So we're done. Okay, this marks the end of this part. And I think that we can take a break. You'll advise me because now I'm going to be moving back to the other tarts, the older tutorials. And then we can do those. But now the time is just immediately 24 past 12 after midnight. And so, yeah, we're going to discuss the other ones. You can advise me at 5 a.m., something like that, if that is okay with you, because you are the student. I don't want to inconvenience you. So the time in the morning must be maybe a very ideal, but I'm going to be moving back to the other things, the older tarts, because this is like most recent. But for you to learn from these tarts, you need to I'm going to make this video available in the next couple of minutes. You can watch it and try to make sense of this video. Yeah, that's something you need to think about. That's something you need to think about. So yeah, it was awesome having this discussion right now until the morning at 5 a.m. If 5 is not okay with you, let me know still. We can do 4 a.m. If 4 a.m. is not okay, we can do 6 a.m. Something like that. Yeah, but please advise. Right, I must thank you for joining us. It's awesome having this discussion. We've taken about 1 hour. Right. And so we'll talk on WhatsApp. Until the morning, thank you and take care and goodbye. Goodbye.